one of the things I really appreciate about your software, we can do it in 90 minutes. We can have 150 people, undergraduates, divided into little lab sections. We can get results, and they can spend at least half of that lab analyzing results, thinking about how you might change how the message was created to maximize attention.
Hello, everyone. Let me introduce Professor Byron Reeves, a PhD at Stanford University. So, a few words about Byron. So, Byron specializes in how media affects psychological process, leading to insights on attention, memory, and emotional responses, with applications ranging from speech dialogue systems to even autonomous cars. He co-founded Human Screenome Project, which I'll be happy to, if Byron elaborates about that in a moment. Basically, the project is to track technology use, like technology engagement in detail for individuals. Also, Byron has led multiple initiatives at Stanford, including the mediaX program, bridging academic and applied research. And I can go on forever with Byron's initiatives, but let me just say hello. How are you, Byron, today?
I'm good. It's good to join you. What time is it where you live, Adam?
It's almost 8 p.m.
Okay, I have to get into that feeling. I'm still drinking morning coffee, so.
I'm having my evening Coca-Cola. Not probably the healthiest one, but sometimes you just have to treat yourself. Byron, can you tell us a bit more about the Screenome project? Like, it sounds really
this came up about 6 or 7 years ago when we started thinking about media use, the concept of media use. So in media psychology, it's roughly divided into go find out what people are doing with media, and then make theoretical and empirical links to different kinds of effects, different ways that people process the information, how much attention they pay, emotional responses. And the history of the field in media psychology, and this is pertinent to your business as well, as well as our research project, but the entire history almost of our field is to go out with a survey and say, Adam, on an average day, how many hours do you spend on Facebook? And just very crude measures of an experience that right now people have a very difficult time remembering because the experiences with media are so fragmented, they're quick, they're across platforms, they join different kinds of content that are radically different. So we started putting software on people's personal devices that recorded every 5 seconds. Great privacy concerns here, and we pay a lot of attention to that. But every 5 seconds on Adam's smartphone, there's software, and it takes a picture of the screen in the background. You don't have to do anything. It takes a picture of a screen and encrypts it and compresses it and transmits it to our research servers. And we do this every 5 seconds. We're starting to do it every 1 second, but we do it for extended periods of time. So the data we've just collected was for an entire year. So these are millions of Adam's screens collected over an entire year. And so we have these long time.
How many Adams are there, just out of curiosity?
This is Adam as in the name Adam.
I know. How many Adams?
How many Adams?
We're tracking
about 1,000 Adams, but we're up to hundreds and hundreds of millions of screens. So we have traded lots of people for lots of information about Adam and the individuals that we have. And then a lot of the analytics are computational, trying to figure out how to get the computer to analyze tremendous amounts of data. So all the AI machine learning techniques that are being used in other areas in medicine and various other computing areas, we're applying to our data.
So what outcome you expect out of this experiment? Like, what's the biggest hypothesis here?
Well, the first thing is just what the heck are people doing with these devices? And the important story there is that the experiences that we're having with these devices are incredibly fragmented, idiosyncratic, very specialized with respect to individual use. There's much less that we can say usefully about how what we're finding apply across a large group of people. But the fragmentation, I think, is the biggest story. So when I'm on my smartphone, the average segment length of these experiences that we have on the smartphone are in 5-10 seconds. The median segment length, they're really short. They are done very much actively at the discretion of the user. No one watches a movie from start to finish. No one reads a news story from start to finish. No one does almost anything without interruptions and without pausing and watch a little bit here. So you see, when you look at the movie of what people are doing over the course of the year, there's just everything joined in these small segments. So you are texting a friend, you are helping a child with homework, you're buying pizza, you're looking at pornography, you're doing work, attending a video conference. So it's just these small little bits that provide this real stew, this chaos of use. So that's what we're trying to figure out so that's the lead thing to say is what are people doing with this? It's really very important to realize how fragmented this is and how unique it is to the individuals that are doing the fragmenting. So that's probably one of the biggest things we've learned.
Very, very exciting. I'll definitely follow this thread. One of the researchers that was using, actually, the eye tracking is being utilized to capture two types of attention. It's so-called focal attention versus ambient attention, and this can be distinguished by eye movements. So I can see that this can even move further, because probably like 95% or something like, or I don't know, 90, I don't know, I don't want to guess, of these actions are happening like unconsciously, like they're just watching the videos, just scrolling without even paying attention to what they're interacting with. So that could be pretty interesting, kind of like next level to see which elements people are actually paying attention to. They're exiting this automatic brain. Probably that's something different.
What are they doing? Interesting to us is what are people doing immediately before actively creating a switch? So what are there different kinds of there might be different isochod journeys that they're taking over a screen, where they're looking on the screen that would predict changing to different kinds of content or actively participating in that. So those are all very interesting. We haven't gotten to those with eye tracking data yet, but those could be very, very interesting.
Could be. Yeah. Moving into the eye tracking field for a moment, I know that you were running your course with eye tracking tool with Real Eye, and I was interested in asking you a few questions about that. So, is the course somehow combined with the Screenome project, or this is something totally different that you're just?
No, it's not totally different, but the course is larger than that. So this is maybe we've used it in two different kind of courses, but the main use and the great appreciation I have for the technology has been to create. So this is a course, first of all, for mostly undergraduates at Stanford. So upper level undergraduates, sophomores through seniors. It's a course that deals broadly with media psychology. So we look at emotional responses, we look at attention and memory, and we look across different domains. So it could be in politics, mental health, education, learning, different kinds of domains. And what we've tried to do in the last couple of years is create, in addition to lectures where we'll go in and review the research and students read material and listen to the lectures. We've had 1 day per week that students participate in a laboratory, and they do the whole laboratory in 90 minutes, and we try to get them to create media, to analyze human responses to media, to simulate the research process as much as possible, but all packaged within the lab. So it's not, and this is one of the things I really appreciate about your software. We can do it in 90 minutes. We can have 150 people, undergraduates, divided into little lab sections, and they may choose. We might provide them content that we're going to look at different characteristics of selective attention and what causes people to change where they're focusing on the screen and how much do they change during the course of viewing. But we can get the license information to the students. We can get their laptops calibrated. We can offer them content. We can get results, and they can spend at least half of that lab analyzing results, thinking about how you might change how the message was created to maximize attention, thinking about effects of good and bad effects of the material, how much kind of visual chaos there is for different kinds of content, and really get people discussing. So the most important part of that for me, I mean, there's an intellectual component to this, but which is interesting. The most important part is we can do it in 90 minutes, and that's what's been really fun.
That's amazing. Great to hear that. We're really happy to hear words like that. That gives us the power to.
We're going to do it again next week. As we we'll have another 130 students next week. And this time, actually, interestingly, in other labs, they've actually created, so they take the research, they take the lecture material, and then we ask them to get out their smartphones and in a group, create a storyboard and build a 1-minute demonstration video. It might be an advertisement, it might be like a public service announcement or interaction for a mental health app or something like that. But they're actually building the content based on research. So now, this year, this is the first year we'll be doing this. Next week, they'll be analyzing with the tracker their own content, and some content that others have built as well. So they can be self-analyze their own work as well as be critical of the other lab groups.
Amazing. So putting it in a process within like 10 years, we're going to have like a perfect app, like iterated 10 times, but by 10 groups.
Maybe, but I think it'll create a little bit more engagement on their part to think, wow, we put this in here, but nobody's really looking down there. They're all looking up here. Why is that? And,
that happens. Yeah.
Yeah.
Were there any actual findings based on the research that happened last year? So, like any interesting findings, insights?
Yeah, there are. So we haven't taken this yet into the domain of our journal publication, scientific research reports yet. But a lot of this is anticipates doing now. So we really haven't done that yet. But I think that we were just talking about. I was mentioning the fragmentation of the different kinds of content that people look at on their devices. One of the there's a corollary to that fragmentation that has been discovered by the groups that are doing this in these lab groups, to be looking at the data, looking at the heat maps, or looking at the different eye gaze pad, totally convinces these students that there is so much going on within the frame, and that it's just not enough to know that I'm looking at this screen. And so this is in the context of the small screen, not the bigger screens, but that it really matters where I'm looking on the screen, because it's held so close to me that foveal vision, and 1 to 2 degrees of arc really can change quite a bit. So the finding about the changes, the quick changes in the in foveal vision, the focus, where the focus is pretty interesting. And then what causes those changes? Students have been very interested in how filmmakers impose on these changes by introducing cuts between scenes, by introducing object or character motion, by dollying or zooming cameras, so you can see, you can count up amount of visual changes that are related to those features, and the students do that. So it's a lot of it is confirmation of what might be intuitive to a filmmaker, but it's really quite nice to have little spreadsheets calculated for the
based on
yeah.
base these types of things
This
on the
is
data.
really so we have never really paid too much attention. So I'm asking you a question now. So, your advice on doing this, but we have not paid too much attention to the motion recognition, the facial musculature points and whatnot. But we're planning on doing that next week, and it, I think largely trying to demonstrate that this is an important method to learn about people's emotional responses. That's quite different from watch this and how do you feel, which doesn't
Sure.
work also.
So basically, what we observed, I assume that the question is how to approach this emotion detectors and so on. So at Relay, we're using something called FACS, F-A-C-S. This is a facial action coding system invented in like late the 20th century by Paul Ekman and group.
Yeah.
So basically, we like to say that it's never telling us about the emotion. It's just telling us about the facial state. And the facial state can represent emotions, like it's another step forward. What we observe is that people do have these facial muscles reactions, mostly for video content. So people in general don't smile and don't get surprised by static content, static images, advertisements that are static or websites. They're just as they are usually. But well-designed advertisement that should evoke, for instance, smile, can actually evoke that, and like we do have some pretty nice use cases that advertisements.
Yeah, we've seen some on your website. Yeah, some of the examples.
Therefore, to be honest, pushing us forward, the topic, there's like we've seen providers that were kind of like able to calculate 30, 40 emotions, and like we don't really feel it this way. So we are convinced that probably the like three basic emotions like happiness, basic like smile detector, surprise detector.
Yeah,
these are the most certain.
We've done a lot of physiological work over the years on emotional responses. So we've been measuring skin conductance levels and heart rate, acceleration, deceleration, and we really like the simpler definitions of motion, and I'm particularly fond of this two-dimensional valence, good and bad, and arousal, excitement, anxiety, and calm, and trying to place media in those different quadrants of that 2x2, because we know a lot about how attention works and memory works for highly arousing content. And
I think that makes sense to measure it in these two verticals. Therefore, it is not straightforward to measure these from the facial movements. Probably the GSR or the techniques that you took are much more convenient to do it. There's one thing that I think there's some, like I mentioned previously, the attention, and we do have also this attention metric again that it's built based on. It's not us who invented that. It was like a bunch of specialists from 2016, including Andrew Duchowski, Krzysztof, and Isabella Kreitz, and these guys' team, that were distinguishing two types of attention based on different eye tracking movements.
Yeah.
And perhaps the valence can have something in common with the attention, for instance. So probably based on eye movements, you can also see whether someone was in active zone or not. That's something probably that's going to move.
So one question that the students ask is who is using your technology, and what are the major uses? Could you just say something about the top one or two uses, and
absolutely
who's paying for this? Yeah.
There's definitely a division between commercial side and a non-commercial. By non-commercial, I mean academics, universities, non-commercial education institutions. Just like you are going to use Real Eye in your classes. There's many different universities who are using it in a very similar way. Also, they're using it for grants, just to run some papers, not for classes, but for some internal research.
Yes.
And there's the commercial side that is using eye tracking just as they were using it 15, 20 years ago. So basically for studying user experience research, in general market research, user experience, shopper research, advertisement research, three most popular use
Mhm.
cases. And the thing is that since they were using already eye tracking, and these were already using eye tracking, it's just a matter of changing the approach on how to get the data. So we're
Yeah,
not discovering new markets; we're providing like new tools for running the same type of data
something
that was out
easier, I
there.
hope. Yeah. What do the commercial people like about Real Eye?
Uh, the, it's time effective and cost effective.
Yeah,
Like what you said, you can have
because you can do
150
it
results
fast.
within
Yeah,
90 minutes, and
yeah,
that's
yeah,
the biggest gain.
yeah.
Question to you, Byron.
Yeah,
You're in
sure.
the you're in the media and human interaction with with media and technology. How do you foresee eye tracking in HCI? I think it's called human computer interaction. Is like I know that there are these Googles and so on, and they're utilizing eye tracking. But how about the interaction with natural screens with smartphones? Will eye tracking be part of it?
Um, will it be part of the research or part of products that are
Part of
built?
the products where I'll
Yeah.
be able to run my smartphones without hands, with
Have
just
you?
with my eyes.
Well, where people are looking is important theoretically and conceptually, and it's I think will continue to be. It's one of those questions that seems like when someone says, "Gee, this screen that I'm looking at Adam on right now is really quite large. You know, it might be 30, 40 inches. I have a large screen, and, you know, but I could be. I'm all of these movements are still looking at the same screen. What am I looking at, and how is that changing?" Um, that's all. It's very easy to get people to say, "Oh yeah, well that's really important." And you know, the Google ad that's up in the upper right should cost a lot more than the one in
Mhm.
the lower left, or whatever. All the metrics for that. Uh, I think that so it's not hard to justify that as an important intellectual topic. What's hard is just get the data. It's just this practical constraint that keeps people from joining in the conversation about the important conceptual issues. So, but if you can make it so that it is not only relatively cheap, but it's the quickness and it's I don't have to go take a course to learn how to operate real eye data collection. You know,
Mhm.
I can I can do it this afternoon, having never done it before. And that's what's really important. I think getting it into this mix of inductive, deductive kind of thinking about media
I
is,
was rather referring to like use of eye tracking in the live engagement with technology. So just
oh,
like controlling a laptop
yeah.
with
Well,
sight and
have
things.
you had the Apple Vision Pro
Not
goggles
yet.
on yet? Yeah.
Therefore, I'm on, I've seen several
Well,
pretty
it's you know I have
nice
not had
reviews.
those on yet, but I'm
Okay.
quite aware of this notion of spatial computing is just really huge right now in the valley right now, and all the different people that are building these devices it's very huge. So you know to know where my eyes are on the screen, and then I pinch
Hmm.
to my
Wow.
mouse is my finger, and so that I don't know how that relates to your technology or whether you can participate in that,
Mhm.
but that is a huge topic for everyone right now is to get
Mhm.
get this different sense of creating a three-dimensional space that I can operate on with my eyes. So
With
I
you.
look at the icon, I
Hmm.
click on it with my fingers, and then develop a new kind of rhythm and pacing.
Hmm. Hmm.
Are you? Is that
Uh,
interesting to you?
yeah. I feel similar. I feel in a similar way. Therefore, I definitely there's a huge chunk of eye tracking in the VR. Therefore, I'm still wondering how it's going to be in future embedded into desktops, laptops, smartphone screens, and so on.
Yeah.
But I'm definitely at the
Well,
same
two
page as you
directions
are.
of the embedding. I mean, I think everybody here is really interested in how do I get rid of the desktop and
Mm,
bring it into the
yeah.
goggles. So
Mm,
it is both directions. Yeah,
yeah.
both directions. But it
Hmm.
involves the eyes a lot.
Hmm.
And when you do that, you start collecting. You start getting more familiar with this notion of gaze and foveal vision and parafoveal vision and peripheral vision and
Hmm.
what's happening there and where um, just all the different psychology that happens in different areas of vision, and it just brings in a lot of new thinking that that hasn't really. We've known about all these things for a long time, but it's just too hard to put my chin in a chin rest and do these calibration schemes that are just
Yeah,
with these delicate, sensitive instruments. Too difficult.
definitely easier to put goggles and and
Yeah,
just lie down, and it's
yeah.
already out there for you for usage.
So I think where people are looking, just the answer to that question becomes more and more important as the technology becomes easier. That yours as well as uh, headsets that allow the creation of or emphasize that this is not one place. This is possible. A million places that I could be looking.
That's right. Byron, thanks so much for having this
You want?
conversation with
Yeah,
me. It was supposed to be a bit shorter, but as usual, we do have
that's fine.
interesting people to talk with, so I don't care. Let's just make the show longer.
Here.
Thanks again.
You're welcome. Yeah, yeah, and all the best to you. Keep inventing. Yeah.
Thanks, and
Okay.
good luck with the project. I will follow for sure.
Okay. Thank you very much, Adam. Bye bye.